To find the least common multiple, you do multiply 4 times 9, and in this case it is the least only because 4 and 9 are called coprime. When you look at their prime factorization, they have no common factors. Therefore, multiplying them all together does give you the least common multiple. However, this question is asking or saying that her age is 2 away from a multiple of 7. So I know that 7 times 10 is 70, and 36, which is the least common multiple of 4 and 9, 36 times 2 is 72. And that is 2 away from 70, and also it still makes Miss Bailey younger than 80 years old. So 72 is the right answer. 36 was close, but it doesn't satisfy the second part of the question. This problem, although it looks strange because of the radical signs, is just one factor multiplied by another factor that is a binomial. So if we apply the distributive property, the square root of 5 times the square root of 2 can be written as the square root of 5 times 2, which is just the square root of 10. And the square root of 5 times negative 3 is just negative 3 times the square root of 5. And that's it. And you could put these numbers into a calculator and they would come out to the same thing as if you use your calculator to calculate an estimate for this expression. These answers are two forms of the same information. Hope this helps. Okay, in this problem, think about any fraction where 4 divided by 4 is 1, or 4 squared divided by 4 is equivalent to 4 times 4 divided by 4. Well, 4 fourths simplifies to just one whole. So 4 squared divided by 4 just equals 4 over 1, which is equivalent to 4. Now this helps you understand why this problem is equivalent to 5 to the 9th power divided by 5 to the 8th power, because 5 to the 5th power is literally 5 times itself 5 times, and then 5 to the 3rd power is 3 more 5s. So altogether, that is 5 to the 8th power. So if you were to divide out all the matching 5/5, you would divide out 8 of those 5s. So this 9 would become 1, because 9 minus 8 is 1. So you're left with just 1 5 in the numerator and just a 1 in the denominator. So the answer is 5. So this problem does fall back on index laws, like it says right here. But basically, this idea of knowing that this is expanded form of 5 to the 5th power and 5 to the 3rd power, and then if you had the numerator, which was 5 times itself 9 times, then each of these 5/5 would become 1. So that is the idea behind the rule that becomes when you divide with a common base, you just subtract the exponents. Hope this helps. You can always find any common multiple by multiplying two values together, and 30 times 18 does equal 540. However, that is not the lowest common multiple. One way to do lowest common would be to multiply out each of the values until you find where they skip count or multiply out to be equal. And I know that I'm going to use 18 and pay close attention to where it ends in a 0 when I use a factor, because I know that all the multiples of 30 are going to end in a 0. So they match up at 90. But really, more importantly, if you know the prime factorization of 18, which is 2 times 3 times 3, and the prime factorization of 30 is 2 times 3 times 5, the way I like to figure out the lowest common multiple is to recognize that if I have a section of a Venn diagram where there are common factors, so 2 and 3 are common of both 18 and 30. And then the other factor that makes 18 is 3. So altogether in here I've got 3 times 2 times 3, that's 18. And then for 30, it's 2 times 3, and the other factor is 5. So these 3 factors are the prime factorization of 30. Now both of these factors values share 2 and 3. So to find the lowest common multiple, I can multiply 3 times 2 times 3, which is essentially 18, times 5, the only other factor aside from the original 18. And if I do that, that's a more advanced way to get the answer of 90. Hope this makes sense. 2 options: skip count or learn how to do prime factorization. And this is more advanced, but takes more practice. Thanks.